Hi, good morning, everyone. Good morning, everyone, and welcome to Cytron's webinar series, our 25th series today. And my name is Adrian. Thanks for tuning in for Let's Learn Arduino Part 3. I see some people are still coming in, but today I'm just going to go through our agenda for today. We have quite a lot to cover for our third session. So a bit about what this session is all about, okay? And because this is a Part 3 session. So Let's Learn Arduino is a series where we learn Arduino by building a coffee pot, right? A coffee pot temperature sensing device. So if you haven't watched the first and second series, I welcome you to join and finish this session first, and then later on you can go back to the first and second part of the series. Okay, I'll be sharing the link for those part 1 and part 2 as well. But before we move into the third session, I'm just gonna explain a bit on the how we do things here in this webinar series. So what we normally do is, if you have questions and if you're watching us from YouTube, feel free to drop your questions in the comment section on your right side. Or if you're watching this through your phone, you can type the comment in the chat box. And I will do my best to answer your questions as fast as possible during the session. So we won't be having a Q&A session depending on the time that we have left. But if you ask the questions relating to the demo that I'm showing during the webinar series, I will be able to answer your questions immediately. All right, so good morning, guys, and thanks for tuning in. Good morning, Miss Tan. Good morning. Good morning, Shaman. And thanks for joining and thanks for tuning in. All right, great to have you guys here. I'm happy to see you guys. And I really hope that there are a lot of you who have gone through the part 1 and part 2, but if no, it's okay. So at least you know what's happening. All right. So let's get started without wasting more time because, again, I said there are a lot of things to cover today. So to go through our agenda, I will do a quick recap on what we did in part 2, and I will show you the hardware that we did together in part 2. And then later on, I will move into introducing you to data types, variables, and array. So bear in mind that we actually use data types variables in the previous example for our temperature sensing device, but I didn't really elaborate more on those. What is data types? What is variables? Right? And the reason why I want to cover data types and variables today is because I want to explain array. It is also one of the data types out there. And with array, I'll be able to show you guys how you can smoothen your analog signals, your temperature signals from your coffee pot. Good morning. Good morning, Over. Good morning, Gobi, Gobinav. Thanks for joining. So this is just 3 things that I would like to cover today, but it's a lot. Right? It's a lot to absorb. I know that it's a lot of things here, and we only have 1 hour. And usually, data types, variables, and arrays is like a multiple classes. Okay, if you join a class, it's multiple chapters. So I'll try my best to put everything into these slides in this 1 hour, and hopefully you are able to understand, you are able to grasp the concept of data types, variables, and array. Okay, so are you guys ready? I hope you guys can hear me clearly. I hope my internet is all right today. Okay. So again, questions in the comment section. I will be able to interact with you. And if no questions, I will move on to our next part of the class. So a bit recap on what we did in part 1. In part 1, we built this temperature sensing device. It basically consists of Arduino, a Maker Uno that we use, connected to LM35, a temperature sensor, hook up to a metal container, and with my my coffee pot, we'll be able to measure the temperature on this coffee pot. Okay, this is warm. I already fill in the water. So in part 2, we actually introduce if and else by connecting some LEDs so that when the temperature is hot, a certain LED lights up, a green LED lights up, a red LED lights up when it's hot, and when it's cold, a green LED lights up. So this is what we did in part 2 using if and else. If it's hot, light up red LED. If it's cold, light up green LED. So this is part 2. Sounds simple enough, right? I try to make it simple as possible so that you can implement this in your own projects. All right, the coffee pot is just an example for this series, but bear in mind that this is the concept of programming. You can use this structure in different types of projects. So I'm gonna bring you to the hardware and show you what we built last week, and then we continue from there. All right. Let me quickly switch my camera. So this is what it looks like. Very simple setup. Okay, I have my metal casing. This is actually a sweet metallic case lah. So it's to store sweets. I finished the sweet, so I took it out and then I mount the temperature sensor down here, LM35 down here to this metallic container. My Maker Uno is connected to the LM35. So this portion is part 1 of this series, and this portion is part 2 of this series. The green LED lights up when this part is cold, and the red LED lights up when it's hot. So simply by placing the coffee pot above, okay, this is the coffee pot here, it will slowly transfer the heat to the metallic and then to the metallic container, and the temperature sensor will be able to detect the heat, and then later on the red LED is going to light up. So it takes some time for the heat to transfer through this setup. Yeah, I will show you again when the red LED lights up, and let me quickly check what's the temperature right now. Okay, from my serial monitor, the temperature right now is 29.79 degrees Celsius. Okay, and then later on, when the temperature hits 30, the red LED will light up. Okay, so sorry. Adjustment. Yeah, the red LED lights up. So when it hits 30 degrees, it lights up, and then when it's cold, the green LED lights up. But bear in mind that it jitters, means that it blinks, blink, blink, blink. It's not really stable because the temperature sensor is measuring very quickly, and it picks up any random noises as well. So in this part 3, we are going to use this technique called the smoothing technique, or the moving average, to smoothen out the temperature signals that we receive from the LM35. Okay. Try putting boiling water into it from Shaman. Yeah, this water is not really boiling right now. I left it here for some time and it's quite cool off already. Okay, let's proceed. So I hope you understand what we are doing here. It's as simple as that. We try to set up this temperature sensing device with a metallic casing. The LM35 sensor is for you to learn about analog signals, and then the LEDs is for you to learn about control structure, conditional statement, if or else, and also digital signals. And then today we will cover more on the data types. All right, so bear with me. I'm going to be straight with you. Today's session is less beginner friendly, but it's still beginner stuff. If you have gone through part 1, part 2, this part 3 will be suitable for you. But if you haven't gone through part 1, part 2, bear with me. Some of the things over here may sound very technical, but trust me, once you get it, you will be able to do more in your project. Okay. I am trying to delay because I want people people to join in for this session. When I start and when you join in between the session, it will become very confusing, right? The things that you absorb is right, half. So yeah, I'm just gonna quickly explain what is data types first, and then after my next few slides, it will become very confusing already. So what is data types? From the word itself, data, you know what is data? Data is right, information. Data is information and types is the journeys. So what type of information are you trying to collect or are you trying to store using your Arduino or in your programming? So every data that we collect have a type. I can give you a couple of examples later, but a data type actually means that it's a system used for declaring variables. Right? When you have a variable, I'm going to talk about variable later as well, but we're going to cover data types first. When you have let's say a number, you have to declare this number as a number, as in either a floating number or an integer. You have to tell your controller, your microcontroller, or your laptop, or your PC, or your motherboard, or yeah, basically whatever you're programming, to understand that this number that I'm giving you is a number and not a character. Okay, you have to tell him what type it is. Bear with me again. I know I'm just using words right now, but later we have images to explain more. So data types is a system used to declare variables of different types, and there are many types out there. Data types helps us to determine how much space it occupies in our microcontroller or in our program. So every program that we write, there's a processes going on behind, and when you have a variable, it stores data into that variable, or when you have a storage, it stores data. So these data types allows you to store a specific size of data in there. Okay, don't fret if you don't understand, it's okay. Again, the easiest example here is a Boolean data type. Boolean is one of the data type that holds two values, one of two values and not two values, and it occupies 1 byte of memory. Byte is like our megabyte, MB and gigabyte, that kind of byte. So byte is the size in the memory, in our storage memory. And 1 byte is equivalent to 8 bit. Okay, you only need to know this. You don't need to know what is bit, what is, you don't have to break down what is bit or what is byte or what is gigabyte or what is megabyte. No, right? It's storage, it's memory for your controller, for your devices. So Boolean consists of two values. It can be either true or false. Similar to lighting up an LED, it can be either high or low, on or off, 1 or 0. So Boolean represents that. Okay, you can't ask him to go with a third value, right? It can only store either true or false. Okay, just understand this, plain and simple. Don't have to delve into what it does or things like that, but it's either true or false. Okay. And then here are the other common data types in Arduino. I only talk about Boolean, very surface of Boolean, but there are still other data types that we normally use in Arduino. Right, the first one that I would like to cover is byte, B-Y-T-E. Byte, like I said, it's equivalent to 8-bit. Byte is also a data type. It stores number from 0 to 255. Okay, you can declare a variable, you can declare a name, and store number from 0 to 255 for byte. And then in character can be ABC as well. But ABCs are also represented in number or in a binary form, but in digits in a way. So character starts from negative 128 to 127. I'm not going to tell you why the number is so specific. Okay, it'll confuse you, but bear with me that these are the rules for each of these data type, and all of these are used for the most common Arduino Uno. Okay, because again, I don't want to delve into why. I'm just gonna tell you what it is. So integer data type, it allows you to store number from negative 32768 to 32767. We are gonna test it out later with our Arduino, with our Maker Uno, and then I'm gonna show you something that maybe you haven't experienced it before from Maker Uno, but it's something that you should try. Okay, and then there's unsigned integer that allows you to store numbers on the positive side. No negative number, only positive. So anything that is unsigned stores positive, 0 to 65535. And then long allows you to store longer number, right? 2 billion, a very long number from negative to positive. And unsigned long is from the positive side. And then float, okay, this allows you to store decimal places, numbers with decimal point. These are just some of the most common data types used in Arduino, in our normal day projects, programming projects. There are more than these data types out there. I don't want to cover all those because there are a lot out there, but these are the common ones. And then, of course, in the last part, I will explain what is array. How do you use array? How can you use array in your coffee pot machine? So bytes. What is bytes? Bytes stores number from 0 to 255. I can declare a number in my Arduino. Okay, a variable is something like this, can be called apple. Apple is a name. Okay, a variable is a box that stores the box with a name apple on the box. This apple box stores a number of 50. I put the 50 inside this box. And then when I declare byte data type to this apple, I write the word byte in front of apple. Clear? I have to write the data type in front of the variable so that it knows that this variable belongs to this, declared as this type. So now apple is a byte data type. I store 50. When I print it out, I open up this box, I'll be able to see 50. Okay, I'll see 50 inside the apple box. And when I key in 259, bear in mind that it is able to store 0 to 255. So I put 259 inside the box. What am I going to get? Okay, these are a very short example. So the number goes from 0, 1, 2, 3, yada yada, until 253, 254, 255. And then it starts all over again from 0, 1, 2, 3. So if I insert 259, I'm going to get 256 is 0, 257 is 1, 258 is 2, 259 is 3. I'll be able to see 3. Okay, in this scenario, let's say you don't understand what is byte and you have a large number, you want to do maths in your programming, and then you key in 1000 but you declare the variable as byte, then it's going to give you not 1000, it's going to give you some other number. Then you'll be very confused, like, I key in 1000, why you don't give me 1000? So you have to take a step back and understand what data type are you declaring. Okay, so this is a very simple example. Byte allows you to store numbers from 0 to 255. More than that, it's going to go back and start from 0, 1, 2, 3. All right. I'm just going to show you what are the the results that you get if you were to declare variables that is not within the range. Right. Same goes to character. So in character, when we program our Arduino, we can, you can actually program a variable with a character. You can print out different characters like hashtags or $sign or question mark, thing like that, by typing numbers, right? The ASCII code. So by typing this ASCII code, you have to make sure that you declare your variable as the character. Again, for those who just joined, Apple is a variable and char, character, is a data type. By writing it this way, it declares Apple as character variable. And by putting in 50 into Apple, you are going to get 2. Why? By referring to this ASCII table, 50 is equivalent to 2. Okay, the 50 is the code, the ASCII code, and then 2 is what you're gonna see, and 2 is a character, right? Everything here is a character. A number is also a character to your computer, right? You can't do maths with this 2 because it's a character. It's not a number. It's not an integer. Sounds confusing, right? Right, but character is character and integer is integer, number is number. So you can't use character to do maths. Over here, we have character Apple equal to 35. So all these examples in Arduino. So if Apple is equal to 35, referring to this ASCII table, you will get a hashtag here, 35. Okay, I think I have some comments like, yeah, it's a bit confusing. I do agree with you. It takes some time to process. If this is the first time you see it, yeah, it takes some time. It takes a while to process it. So bear with me, but I would like you to try it out yourself. So here, I have a simple example. I'm gonna come up with a simple example, a simple sketch. So let's say you have an Arduino here. You are connected to a Maker Uno or an Arduino Uno. So I'm connected to my Maker Uno. I want to try this experiment out. I want to try this example out. So what should you do? So simple, you declare your variable as a character, like what I showed over here in these slides. So character, char, Apple. Apple is a variable. I can put orange as well. Equal to, so let's say I want to print, okay, I don't want to print hashtag anymore. Let's say I want to print a $sign, 36, ASCII 36. So I will just write 36 in colon. So this allows me to print a $sign. But how am I going to see my $sign? So I need to enable my serial begin, which I covered in part 1. But I'm going to show you again. Serial begin 9600, the baud rate. And then in the loop, I'm going to write serial print Apple. I put a small delay so we can see the data. So this is how you do the experiment, by looking at what is Apple 36 in the variable. So upload your code into your Maker Uno or whichever Uno Arduino that you have. Upload it, and then you will be able to see at the serial monitor that it's printing Apple. Apple is this, and this is equal to 36. And 36 is a dollar sign. Can you see? It's a dollar sign. So it's not printing 36 for me. Why is that so? Why is it not printing 36 for me? So something for you to process a bit. But let's continue on with our 4 examples down here. Character is very special. If I want to print a character, I want to print A, or I want to print ABC. How should I do it? How should I write it? This is something very confusing for everyone. Even if you practice programming for some time now, sometimes you'll be thinking, hey, should I put how many colons are there? What's the right way of printing a character? So let's try all of this out. Character, apple equal A. What do you think? Do you think I can print? Okay, I'm gonna hash this up so that it doesn't clash. I'm gonna print this. Can it print? By the way, this double hash means that this code won't run in your program, in your controller. So will this apple be equal to A because I declare it as a character? Will it be able to show me A, or will I be able to upload it at all? So click upload. And then what's going to happen? You can't even compile this because A was not declared in this code. You will need to use quotation marks. You have to use quotation marks, but numbers are not necessary. So if you don't use quotation marks in numbers, it will automatically refer to the ASCII table. 36 is equivalent to what? So now I want to print A. It still doesn't want to print. So I put my quotation mark over here, single quotation mark, and then I upload it. Will I be able to print A? I want to print A right now. So yeah, I managed to upload it. And what am I getting? I'm getting A. Do you see? I'm getting A. So this means that to print a character, you need to have your quotation mark on the character. But if I want to print ABC, can I do this? ABC. What's going to happen now? Upload it. Will I be able to see ABC, or will I be able to see A, B, or C? Okay. So over here, I will be able to see C. Can you see? I won't be able to see A, B, or C. It will only print the last character in this whole row. There's no compiling issue. You can still upload your code, but it's going to let you see only the C. So yes, if you need, like what Shaman said, if you need multiple alphabets, you will need double quotation. The color will change as well, become blue color. So upload it. Okay. Once you're done, over here. Yeah. Oops, let me close this. Okay. So it's showing me ABC in the character form. So this is like undefined character. Clear output. Okay, but over here, the variable, it registers apple as ABC, okay? So this is how you should write apple, store the variable of ABC, multiple characters. All right. I would like you to give it a try. Okay, if you have an Arduino at home, or if you're using Python, you can open up and give these characters a try. Try different variables and then experiment and see what are the differences, okay, between different way of writing a syntax. Moving on, integer. So integer, like I said, it covers a range of numbers, negative 32768 to 32767. If you type a number more than this range in your integer, it won't show you that number that you want. It will only keep within this range. So similar to byte, when you type 32768, you're going to get negative 32768. It will go back to the front, and then it will go from the front again. But why normally in Arduino we always declare integer? Because integer, it covers the range of numbers that we want to do our calculation. We don't go over 30,000. All right, but sometimes there are one of the common examples is that we want to declare, okay, let's say I declare the integer apple into integer, and then I want to put number. I want to delay this 50,000 millisecond. So I will type delay apple. So over here, I expect that apple is going to delay for 50,000. All right, because I write 50,000 here, I put apple in here. But in reality, apple is not receiving 50,000. So let's upload it. And then we look at the serial monitor. Right, in reality, the apple is not storing, it doesn't store 50,000 over there because the data type integer doesn't allow you to store 50,000. So over here, you can see that the code just hangs there. It just stops there because you're delaying negative 15536 over there. So this is one of the common mistakes done around now, done by people. When you want to set a variable for your delay, you have to make sure that the number that you give him, right, the variable is able to handle that big number. Okay, so bear in mind that when you use your variable, make sure that what's the capability of this variable or the data types that you're using, right? How big the number it can store in. Okay, moving on. So just now we talked about integer, and then I did talk about these are the other types of data types. I'm not going to cover every single one of it, but I'm just going to show you that I stopped at integer here. But what if I really want to delay 50,000, and which data type should I use? So there are also other data types like unsigned integer or long. Long allows you to store a larger bytes. It has a bigger storage for this variable, for this data type. It allows you to store numbers up to 2 billion, and you can use long instead of integer. Unsigned integer is mostly positive. You can also use this, but bear in mind that it only go up to 65,000. So for this case, I can just simply type long. And all right. So in this case, I am able to see 50,000 now. This 50,000 is being pushed into my Apple delay 50,000. My code is getting a 50-second delay right now. Okay, we will come back here later. After 50 seconds, you'll be able to see another 50,000 reading here. It means that it's running and it's delayed for 50 seconds. So any questions so far, guys? Any questions? I hope you are able to catch up. Okay, I'm going as slow as I can. I'm trying to make it as easy to understand as it's more applicable in a way, right? When you are trying out in your Arduino, you'll be able to see what's the problem there. See, I think we have one question here. Find the type used by a variable is not support such type of function in other language. Is that true? Find the type used by a variable is not support such type of function in other language. If I'm trying to understand what you are asking is that some languages don't support the similar data type. Okay, true. So it depends on what are the languages that you're using. Certain data types are meant for certain features, like Arduino IDE. Okay, they have the standard types of data types, but some other languages, it introduces different types of data types as well. So you have to explore that language. But again, the data types that I've gone through are the common ones that can be found in different languages. So yes, your question is true. All right, back to this. Okay, 100 seconds has passed. You'll be able to see multiple readings of 50,000. It means that the code is running with a delay of 50 seconds. Okay, so with long, you will be able to insert 50,000 into the variable of Apple. And Apple is able to print out 50,000 and delay for 50,000 milliseconds. So something lighter right now. I'm going to introduce something lighter, nothing more on the data types, but more on variables. I keep mentioning what is variable. And after presenting this, I figured that I should actually talk about what is variable before I move into the data types. So I'm sorry about that, but I'm still going to go through what is variable. A variable, in this case, is a box, and the box is named with Apple. So I've been using the example Apple, a lot of Apple, right? So this box, the name of this box is called Apple. Okay, this is the box with the name Apple. I declare this box with a data type, and the data type right now, I want it to be integer. So I write int. Okay, small letter, int. So integer Apple. And I'm going to keep the number 8 inside this variable. So this image over here basically is represented by this line of code. Integer stored in the Apple. So the box only keeps numbers, integers. Okay, if you put ABC inside, okay, no, it's not going to work. It's going to turn into integer. And if right now I'm storing 8 inside, so the variable here is Apple. Okay, I hope you understand this because I'm going to move into array next. And if I want to talk about array, I have to make sure that you understand what is a variable as well. Okay. So what is an array? See, now I have more boxes of Apple. I have box 1, box 2, box 3. I have 3 different boxes with array. So array represents a series of an array of boxes, okay, an array of variables, a single variable of array of storages. Okay, it's no longer just a single box. A single box is one variable. Right, an array is that I have this one big box that is able to store many smaller boxes inside this big box. And this big box name is called Apple. All right, Apple. And I will label the boxes with Apple 0, Apple 1, Apple 2. And then every boxes here can store different numbers. Can store 8, can store 5, can store 3. When I want to call this array, I don't just say, hey, what's the number in Apple box? No, because there are so many Apple box right now. I have to tell them, what's the number in Apple box number 2? Then you're going to tell me Apple box number 2 is 3. Okay, so the number in here is called index. And in programming, depending on what language, most of the time it starts from 0, 1, and 2. The first box starts from 0, second box 1, third box 2. Okay, but this depends on the language that you use. Okay, some starts with 1, 2, and 3. Right? In this case, Arduino, it starts from 0, 1, and 2. So again, in array, I'm just going to repeat myself. I want to find out what's the number in Apple box number 1, index 1. And then the program is going to find these boxes, take out the boxes Apple 1, and open up the box and show you the number is 5. You can't ask the program to tell you what is in the array, what is in the variable Apple. If you do that, sure, it's gonna open up all the variable in the boxes. It's gonna tell you number 1 is 8, number 2 is 5, number 3 is 3. So it's gonna tell you all whatever that is inside there. Okay, all right, you can do that as well. Right. So in an array, there is this important thing that you need to know is the array size. How many boxes are there in this array? How many slots are there for you to store your numbers? So this is called array size. So in this case, very direct, right? Very simple, right? The array size is 3 because you have one box store 8, one box store 5, one box store 3. But there are a total of 3 boxes and the array size is 3. So just understand what is array first. Right? We are not going to go into the program yet. I just want you to understand the concept of an array. Okay, array is very useful when you want to store a lot of data and you want to keep it for something useful later. You don't want to create 10 different names of variables just to store 10 different data. You want this data to, keep on coming in and keep on be stored in the same variable. One of the example is our coffee pot temperature that we want to store. And yeah, that's the later part. Let's go through what is an array first. But the array, so remember there are array size. First, you have to declare the array size that you want to have. In this case, I have a variable named my pins. Pins are your pins. And then I declare this variable as an integer. You already know what is data type, huh? So integer, my pins. And this bracket over here, you can fill it in with the size of your array. In this case, I leave it blank. I let it decide what's the size that I'm gonna put in here. So over here in my array, I have 5 digit, 2, 4, 8, 3, 6. When it's 5 digit, it means that the array size is 5. My size is 5. I can store 5 value in 5 different boxes here. So in serial print, my pins 2, what do you think I will get? What do you think I will get? Drop your answer in the comment section right now while I program this in my Arduino. What do you think? What will I get? What number will I get if I call this my pins 2? Okay, someone answered 2. 8. Okay, someone gave the answer 8. Anyone else want to try? So I'm uploading my code right now. So my pins 2, remember this, it starts from 0, 1, and 2. And if I call 2, it's gonna be 0, 1, and 2. So Mr. Lim is right. The answer is okay. I'm just gonna show you the answer from my serial monitor here. The answer is 8. So it starts from 0, 1, and 2. So the answer is 8. Right? Don't get confused. If I say 2, it doesn't mean that it's 1, 2. It's 0, 1, 2. Look something like this. 0, 1, 2. So it's going to give me 8. Okay. Another example here. So just now I mentioned that this bracket over here, it represents the size of your array. You can also declare your array with a specific size. In this case, I tell him, okay, your size is 5. And here are the 5 digits that I want to store in my array. So naturally, this array is fixed to 5, size 5. All right, it's not constant, it's not really fixed, but you can always change this number. All right, so 5, 1, 2, 3, 4, 5. Another example is, I would like to declare my array size as 10. I fill in the number here, 10. But I only give 5 different digits to store in this array. So naturally, the first digit will be 2, and then 4, 8, 3, 6. So what happens if I print my pins 7? There's only 5 digits here. So what it's going to give me? Right, this is another mini quiz. Do your best. Give me an answer. Drop your answer in the comment section while I program this. So I put 10 here. What do you think the answer is? Okay. My screen become blur. All right. Let me repeat again. I hope you can see my screen better now. So over here, this part is where you declare the size of the array that you are going to store your digits. And over here are the data that I have. I have only 5 data that I want to store in 5 array size. I will occupy 5 spaces in the array. But over here, I have 10 space in there. So I have 10 different boxes. I only store 5 digits in 5 boxes. 1, 2, 3, 4, 5. And then now my print here, I'm asking, hey, give me the number in the 7th box. What's in the 7th box? Tell me what's in the 7th box. So what do you think it's going to open up and discover? Is it going to see another special magic number? Right. So I think we have some answers here. All right. Some are very professional, good answers. And I believe all are correct. So the answer is very straightforward. It's a null or a 0 in this case. In Arduino, it's going to show you 0. Right. It's not going to show you a null. It means that there's no number in there. There's no number in there. There's nothing in there. There's nothing in the array. And you can still print it. There's no compile error. You can still upload it, but it will remain empty. But certain languages, it will have compile issues. But in this case, it will be 0. You will be able to see 0 over there. But be careful when you declare an array for a specific size and you don't put anything in there. Right? It's gonna cause issue in the future. Okay. So moving on. I have 10 minutes left, but moving on, this is the main focus of today's session actually, right? How to build the smoothing signals for your temperature signals in your coffee pot, in the coffee pot that we have. The reason why I want to talk about data types, I want to talk about variables and arrays is because doing this function to smoothen your temperature signal requires you to understand the basics of array. And to learn about array, you need to understand about variables and data types. So here it goes, a little bit of math. I hope you can understand simple math. I have these random signals. Ignore the time, ignore the inconsistency of this signal. But I have this, and also ignore the scale of this, like 1, 2, 3, 4. I have this 6 signal, 6 point, 1, 2, 3, 4, 5, 6. 6 point signal. I want to smoothen these signals that keeps coming in. It's very noisy, up and down, up and down. So how do I create a smoothing algorithm to, make sure that the signals smoothen out? This is just to explain the smoothing algorithm concept before we move into Arduino. So I hope you understand this. First, you will need to add all 6 points. 1, 2, 3, 4, 5, 6. So I got 2, 3, 1, 4, 2, 3. Total up, I get 15. How many points are there? 1, 2, 3, 4, 5, 6. I got 6 points. So there are a total of 6 numbers here. And then, how am I going to get the average of these 6 points? I divide it into 6. By dividing into 6, I declare my next point as the average point, 2.5. Okay, this is called a moving average, means that every next signals that you get is the average of the past specific number of signals. In this case, my sample size is 6, or my n number is 6. I collect the 6, let's say, temperature signals. I store my 6 temperature signals. First temperature, second temperature, third temperature, fourth, fifth, sixth. I store all these 6 temperature Celsius data, and I divide them by 6. And then I'll be able to get an average temperature value for my next point. And then moving on, I want to find the next point again. So I will use back the past 6 point again. So 1, 2, 3, 4, 5, 6. So the first point, I discard it, I minus it, I minus the 2. And I will use the next past 6 points. 1, 2, 3, 4, 5, 6, and divide it by 6 again, and I'll get my next point. So this graph, it will shows you that, okay, it really slowly dies down and then it becomes a flat signal. But that's not what we want. That's what we are getting here right now. All right. It is just to explain how this smoothing works, this moving average works. It's basically to collect a specific number of data, add all together, divide by the number of data that you collected, and then you get your next average point. Okay, process it a while. Take some time to process it. I don't expect you to be able to grasp the concept, but this is what you basically will be able to see. This is the temperature signal that I got from the coffee pot. This blue color signal is the LM35 signal. All right, a lot of noises in between. And then once you get the smoothing signal out, the signal will be, the red color line, it will be smoother. So the larger the points that you use, the sample size that you use, the better the smoothing is. But of course, sometimes it becomes over smooth. But if you use a larger sample points, for this case, a random point over here, this is because there's intermittence. I move the signal a bit and then there's a spike. But if you have a great number of samples, it won't 100% ignore the spike, but it won't jump that high. It will just, this is a very random signal. I'm just gonna smoothen it to the next signal. It won't affect your final results that drastically. Okay, that's the whole reason of a smoothing algorithm for your Arduino. All right, so moving on. Again, I hope you don't, get shocked from all of this. But again, this is a continuity of the previous session. There's always ways to improve your project. And in this case, the coffee pot that we are building here. Right, this is the program that I use. Okay, this part is where I do the filtering, the smoothing part. I'm not going to explain all of this. I have a long slide to explain this in the detailed form, in a more detailed way on how you can understand every iteration to understand the concept of this smoothing here. But if you want to learn more on those, I can send you my slide. You just need to go to our Telegram group later and ask for it, and I'll be able to send you a copy of the file. But if you want to try to look at this code and try to understand it, or you can even upload it into your Arduino to experiment it, by all means go ahead. So if I upload this code, all right, I already have my circuit here. Okay, let me just quickly switch my camera. Okay, I hope my coffee pot is still warm. And then I go to serial plotter. Oh, sorry. Serial monitor is on. Go to serial plotter. Okay, so this is what you're going to get. At the beginning, the average value is going to add up, add until the point where your actual average value is. So there are like 10 values over here. My sampling size is 10 data. So it takes 10 and then slowly it filters down the signal. So you see there are a lot of noises from my temperature signal, up and down, up and down. Okay. And then I'm gonna put my coffee pot here. Hopefully the temperature is still there. I'm gonna add some hot water. Okay, with some hot water, the temperature should slowly spike, right? Slowly increase. And when the temperature increase, it reach 30 and above, the red LED is gonna light up. Right? But it takes some time for the heat to transfer down. You can see that the graph is slowly moving up. Slowly moving up. The blue color is the signals from the LM35, the temperature sensor. It's raw data, but converted into Celsius. There are a lot of noises in between. Okay. Yeah, you can see the red LED lights up already because it reaches the 30 °C here. But in this case, I'm not using the signals that I'm collecting from the temperature sensor, the direct signals. I did some simple data science. I did some simple signal processing so that the signal is more stable. And when it goes above 30, it lights up. Okay, this is definitely some noises here already. I think the sensor loosened up already from the metallic container. All right, that's a long jump over there. Okay, guys. So I hope you enjoyed today's session. This is all I have for today, but I hope you really learned something new. I understand it's a bit more than what a beginner should learn, but if you watch the part 1, part 2, and then you watch into part 3, this is the continuity of the Arduino, right? Most of the students, they stop here, or they stop before here and just collect normal signals. But I encourage you guys to try different algorithms to improve your signals. Right? In a lot of projects, we do data acquisition. We collect signals, and then we directly process the signals. We directly translate the signal into results. Right? Turn on and off an LED. But in reality, we can do more. We can process our signal and give us more accurate results. And that's what we want. Okay, so this is just one of the examples, smoothing temperature signal. It's using time domain. That's another topic for this, where you use frequency domain, or use Fourier transform series, or use FFT. You use different ways to get more accurate results that you want. But I am going to leave that to you to explore in the future, okay? So guys, as always, if you enjoyed today's session, or if you want the slides for today's session, join our Telegram group. I will be there. Just ask in the Telegram group. If you have more questions that you would like to learn more, you want to understand more about today's session, or even the past session, join us as well, and You can ask your questions there. Okay. Junior makers assembles are built for students, but if you're an adult, we welcome you as well to help us push our students community in learning Arduino and also digital making. And I know some of you guys are here for the certificates. So here are the certificate link. If you have feedback, do drop us a feedback. What do you think about today's session? Do you like it? Do you think it's too complicated? Do you want something easier? What topic you want to hear in our next session? Let me know. Go into this link, and then drop your feedback. Okay, I'm going to share the link in the comment section here. I've dropped the Telegram group link in the comment section as well. If you want to join us, just click and make sure you have a Telegram account. Join us there. Ask us questions over there. If you want the slides, it's all yours. You can use the slides. Okay, and let me go back to the slides here. Okay, scan and join our Telegram group. All right, here's a quick one. But again, if you join into this session, if you join late into today's session, don't worry. This webinar series is a recorded session. You can always go back to Citron Tech YouTube channel and rewatch the Citron webinar series. Okay, you can find the YouTube in the same link here. It's recorded. Yeah, guys, yes, you can fill in the link and get the certificate. An e-certificate, make sure you fill in the correct email address. I've been receiving a lot of wrong emails lately, and then you guys won't be able to receive the certificate if you give me the wrong email. Okay, I won't be able to reach out as well because I got the wrong email. So make sure you fill in the correct detail. All right, as always, thank you guys for tuning in today's series, and I hope you learned something. All right. Yep. Again, I'll see you in a Telegram group, and I'll also see you in our future session. So thank you again. Thank you guys, and I will see you soon. All right. Goodbye.